Hello everyone. The title of this video is Solving Linear Inequalities in One Step. Now some of the inequalities that I'm going to be solving, yes, you can do them in one step, but if you'd like to slow it down even further, you can do some of them in two steps, which I'll show you both varieties. And yeah, this is just me going through and writing kind of like a solutions manual to the openstacks.org Intermediate Algebra 2nd edition textbook. Let me show you that. Pull up the website here. So this is openstacks.org, their Intermediate Algebra 2nd edition, and this is section 2.5 in that particular book, Solving Linear Inequalities. And what I'm doing for this video, I already did a video on other inequalities here, graphing inequalities and writing the solutions in interval notation. What I'm going to be doing here are exercises 304 through 311, solving all these inequalities. And the instructions are, solve each inequality, graph the solution on the number line, and write the solution in interval notation. Alright, this is what I'm going to be doing for all the, I think I have 20 examples. Alright, and if you don't want to watch all 20, of course, that might be a while. That might be a long watch. I will have in the description of the video, I do have the timestamps for when each example begins. So if you'd like to skip around more easily to different examples, and if you happen to have, this is a free online textbook. If you happen to have this, section 2.5 of the Intermediate Algebra 2nd edition up, you can see what example is what. This is example 20, number 311, part B. This is example 1, 304, part A. So if you'd like to see any one in particular, you can skip ahead to that whatever number example. Okay? Alright. So the first, again, the instructions are solve the inequality, graph the solution on a number line, and write the solution in interval notation, which the graphing and writing in interval notation, I've done that in a previous video, and hopefully you've seen that. Alright, so the goal is to, solving a linear inequality is just like solving a linear equation. Right? The goal is to get the variable, the unknown, alone on one side of the equation, or inequality in this case. Now, my preference, and I think most people's preference, is to have the variable on the left side of the inequality. Right? So I'm going to, in all the examples I do in this video, I'm going to have it set up so that the variable that we're looking for is on the left side of the inequality symbol. Doesn't mean you can't have it on the right. Of course you can have it on the right. It's just like I said, I find that most people tend to prefer, me included, the variable on the left side to make it easier to read and understand. Alright, so the steps in solving a linear inequality are, just remember that whatever you do to one side, you have to do to the other, right? So, I'll write that over here. What you do to one side of the equation, add, subtract, multiply, divide, you have to do to the other, the inequality, sorry, you should be doing to the other side as well. So what you do to one side, also do to the other. Okay, so that's one thing. And then a couple notes. The inequality symbol this particular one, if you're reading it from left to right, is the is greater than or equal to symbol. That can flip around. It can become is less than or equal to if certain things happen. So the inequality symbols can flip if certain things happen. So you flip the inequality symbol. Right? So is less than becomes is greater than becomes is less than, etc. Flip the inequality symbol if you multiply both sides or divide both sides, just multiplication and division, by a negative number. So if you multiply or divide, right, because division is just multiplication by the reciprocal. Hopefully you recall that. If you multiply and divide both sides by a negative number, right, negative number only. Right? If you multiply or divide both sides by a positive number, the inequality symbol will stay the way it is. You do not flip it. And one other thing I'm going to do in this video that will flip the inequality symbol is switching sides. Like if you, for example, if I read this inequality here from left to right, it's a plus 3/4 is greater than or equal to 7/10. Well, if I switch the sides, if I put 7/10 on the left side and a plus 3/4 on the right, that will switch the symbol. So instead of is greater than or equal to, it'll be is less than or equal to. Right? But like I said, I'm not going to work with this. I'm going to leave my variables on the left. But switching sides, if you change the position, change sides with the expressions, the inequality symbol flips. Because if you read it from left to right, it's a plus 3/4 is greater than or equal to 7/10. But if you read it from right to left, it's 7/10 is less than or equal to a plus 3/4, and that's what I've written here. So switching, I'll say switching sides flips the inequality symbol. All right, and those are the only two things we're going to have to worry about, when the inequality symbol flips here: multiplying or dividing both sides by a negative number, or switching the expressions on the sides, switching the expressions. Okay. All right. So as I mentioned, not going to work with this one here. I'll leave it so that whatever expression has the variable, I'm going to put that on the left side. All right. Now I just wish to isolate the variable, get it alone. So here I have, a plus 3/4 is greater than or equal to 7/10. If I want the a all by itself, I need to get rid of this plus 3/4. And the way to get rid of addition is through subtraction. Right? So what I'm going to do is I'm going to subtract 3/4 from the left side, also subtract 3/4 from the right side. And now this is subtraction, right? Addition and subtraction will not flip the symbol. So yes, you're seeing a negative number here, but this is subtraction. We're not multiplying or dividing. Right? We're not multiplying or dividing by a negative number. We're just adding or subtracting. So on the left side, I have a all by itself now is greater than or equal to, and then over here we have 7/10 minus 3/4. Right, I'm working with fractions in this first example. Now don't forget that you can't just add or subtract any fractions. And you don't just I can't take 7 minus 3, 10 minus 4. You can't do that. you need a common denominator, right? You need a common denominator. So I look at the denominators 10 and 4 and find a common multiple of those. Now the smallest or the least common multiple would be 20. So what I do then is multiply this first fraction by 2 over 2, right? That way it's like I'm multiplying by 1 and not changing its value. And that'll give me a denominator of 20. And the second fraction, the 3/4, I'd have to multiply by 5 over 5. Right? Again, that way it's like I'm multiplying by 1, not changing the value of 3/4, and give me a denominator of 20. And so this here now is 14/20 minus 15/20. Okay. And then once you have that common denominator, then you can do the addition or subtraction. And the common denominator stays, right? So it's going to be 20ths in the denominator still. And you just combine the numerators. 14 minus 15 is -1. Right? And there we go. Right? I have solved this inequality. I've gotten the variable alone on one side and then some number on the other. And this, when you do that, you have described the solutions to the inequality. Right? Every value of a that I can replace, every number I can replace a with to make this a true statement is any number a that's greater than or equal to -1/20. Alright, so there's part 1, solve the inequality. Part 2 is, graph. This, anytime you see the word graph, that just means draw a picture of the solutions. Okay, so here's a number line. So you got 0 there. And then you pause it. Hopefully you know how to real number lines set up. And we're trying to draw a picture of all the numbers that are greater than or equal to -1/20. Now say there's -1. Now -1/20 would definitely be between 0 and -1, very close to 0. Right, say here's -1/20. Now all the numbers greater than -1/20 are to the right. So these numbers here, so I'll indicate that with a little mark arrow, right? And then -1/20 itself is also a solution because it's greater than or equal to. So that might be indicated by just a closed dot above -1/20, or in some books you'll see the rectangular bracket. So you might see this, or you might see this with a closed dot and then an arrow. Same thing. Either way, it's indicated that -1/20 is a solution. All right, so there's the graph. That's the second part. And then write the solution in interval notation, which again, hopefully you saw a previous video of mine. You always draw intervals from left to right. And again, we're describing the same set of numbers. We're describing the solutions of this inequality. So this picture of solutions here, on the far left of it starts at -1/20. So I'll write that, going left to right. Then a comma, and then where does this piece of solutions end, this interval of solutions? It doesn't. It goes to the right forever. So I indicate that by writing the positive infinity or just infinity symbol. And then you cap the ends off, and you cap them based on whether or not those numbers on the ends are solutions. Well, -1/20 is a solution to this inequality, so I use a rectangular bracket, right, instead of a parenthesis. And don't draw this too fast, right? You might, if you draw it too fast, it might look like a parenthesis instead of a bracket. And then infinity is not a number. Right? It's an idea, a concept going to the right forever. So you always have parentheses on infinities to indicate that they're not solutions, right? So here we go. I'm done with this first example. Now the first one, obviously the first few examples here are going to be the slowest ones. And then as I go through, I'll do them much faster because they're all pretty much the same. Where I get the variable alone on the left side, describe all the solutions, Then I draw a picture of those solutions on my graph on the number line here. And then once I have a graph, it's easy to draw, the interval notation for that set of solutions. Every number from negative 1/20th and up is a solution to this inequality. Okay, so hopefully that was clear. And again, I'm going to move on to the next example. All right, so let's move on now to the next example. In every example, the next few pages, every page here on out, I have a couple examples. The next problems in the OpenStax book. So again, same instructions: solve the inequality, graph the solution on a number line, and write the solution in interval notation. All right, so here I have 8x is greater than 72. So already the expression with the variable x is on the left side, so I'll leave it this way. And I don't want 8x, right? I want 1x. Now this is multiplication, right? 8 times x. And to undo multiplication, you divide. So I'm going to divide this side by positive 8, right, to make it into 1x. And again, what I do to one side, I do to the other. Divide that side by 8 as well. And this is division by a positive number. So the inequality symbol will not flip. Right? If I divided both sides by a negative number, then when I do the next writing, I would flip the inequality symbol. But here I am not doing that, right? So we have x alone by itself, 1x on the left, is greater than still, because I divided by a positive number, still fine. And then 72 divided by 8 is 9. And there we go. That's part 1. I solve the inequality. All the numbers that are solutions to that original inequality, numbers that I could plug in and make a true statement, are all the numbers greater than 9, but not equal to 9. Right? So when I do the graph, here's a number line. Again, just say here's 0, and the number 9 would be to the right of 0 somewhere, right? Let's say here. Just mark off the number 9. All the numbers greater than 9 are to the right of it, right? 10, 11, 12, and so on. But not equal to 9, right? 9 itself is not a solution. So one way to indicate that is with a parenthesis. Little curvy parentheses there. That indicates that 9 is not a solution. Or in some other textbooks, you might just see an open point. And then, the arrow to the right. Either one of these is fine. But usually, you get either an open point or a parenthesis above a number that is not a solution. Okay, so there's the graph of the solutions. And then in interval notation, I'll just write the word interval right now. Just going from left to right here, this piece of solutions, this graph starts at 9, doesn't end, so goes to a positive infinity again. But 9 is not a solution, so I put, again, I capped the 9 off with a parentheses. And infinity is not a number, right? Always capping off infinities or negative infinities with parentheses. Right, so there's the description of the solutions in interval notation. All the numbers greater than 9, but not equal to 9. Okay, simple enough. All right, my next example. All right, now this is 20 is greater than 2/5 times h, right? If there's no symbol between, that means there's multiplication, right? Just like 8x. All right, as I mentioned at the top of the video, I'm going to set things up so my variable is always going to be on the left. You don't have to, right? You absolutely do not have to. So what I'm going to do is I'm going to switch sides here. So I'll write the 2/5 h, 2/5 times h on the left, the 20 on the right, and don't forget what I said earlier. When you switch sides like I just did, you should be flipping the inequality symbol as well, right? Because if I read this inequality that I started with from right to left, that'd be 2/5 h is less than 20. Right, so notice the flip in symbol. Okay. All right. So now I know I said the title of the video, these are inequalities in one step. You can do this in one step. This is 2/5 times h. To undo multiplication, you do division. But dividing by a fraction is ugly. All right. So remember that division is multiplication by the reciprocal. So if I would like to get rid of the 2/5, I can multiply by the reciprocal, which is 5/2. And then hopefully you can see that the 2's would cancel, the 5's would cancel, right? And you'd have just 1h. And I do the same thing over here, multiply this side by 5/2. And you could think of 20 as 20 over 1, right, if you wanted to. Same thing. And that's a positive number, right? I multiplied both sides by a positive number, so the inequality symbol will not flip. It's going to stay is less than. So I'll have 1h is less than. And then, when you multiply fractions, you just multiply the numerators, multiply the denominators. This over here is 100 divided by 2, which is 50. Now you could also do the canceling first. You could also do, hey, 2 goes into 20 10 times, and then 10 times 5 is 50. Either way, it's 50, right? And yeah, you don't need a common denominator when you multiply fractions. Okay, please know that. You only need that common denominator when you're adding or subtracting fractions, like in my first example. And there we go. So the numbers that are solutions of this inequality are numbers that I can replace h with. I can replace h with any number less than 50. And that initial inequality would be a true statement. And you could test these out, of course. You could say, hey, numbers less than 50. How about 10? If I put 10 in, you'd have 20 is greater than 4. That's correct. If you put it in negative 100, you'd have a true statement, and so on. Put in any number less than 50 for h in the original inequality, and it'll be a true statement. And here's a number line. Right, here's 0, and 50 would be to the right of 0 somewhere. Right? I'll just put it to the right of 0. And our graph consists of numbers that are less than 50. That would be to the left, 49, 48, 47, etc. And, but not including 50. Right? So a parenthesis on that. Or an open point, right, to indicate that 50 is not a solution. And then in interval notation, looking at this piece of solutions, this graph here, going from left to right, well, there is no furthest left number, right? This is going to the left forever, so I'll indicate that with a negative infinity symbol, right? Indicating that this piece of solutions goes to the left forever. And then it ends at 50 on the right. And as I mentioned before, you always cap the infinities with parentheses. And I said 50 is not a solution, so you cap that with a parenthesis as well. Right? So there's the interval notation to describe the numbers less than 50 but not equal to 50. Okay. Like I said, all these examples, pretty much the same stuff. So might get a little faster here. So now example 4. We've got b plus 7/8 is greater than or equal to 1/6. So this is pretty much like example 1 with the fractions. I want, again, my expression with the variable is already on the left side. So I'll keep it there. I'm not going to switch sides. And I want to get rid of this plus 7/8, which will involve subtraction. Right, so I subtract 7/8 from both sides. So now I have just b alone on the left side, which is what I want, is greater than or equal to, right? No, yes, there's a negative number here, but I didn't multiply or divide by a negative number. I added and subtracted, That doesn't change the symbol. Right? And then just like before, off to the side, 1/6 minus 7/8. I can't put these together right now because they don't have the same denominator. When you add or subtract, you need a common denominator. Now, you could just do, 6 times 8, make 48 the common denominator, but there is a smaller number that both of them go into, and that'd be 24. So I can multiply this fraction by 4 over 4, right, to get a denominator of 24, and multiply the 7/8 by 3 over 3 to get a denominator of 24. And so we'd have, 4 24ths, right, that's the same as the 1/6, minus, and then 21 24ths, right, that'd be the same as the 7/8. And I got a common denominator here of 24, so that'll stay. And then 4 minus 21 would be negative 17. Right, negative 17. So B is greater than or equal to negative 17 24ths. And there we go. Right, there's the inequality solved. Right, the variable alone on the left side there. And then a graph. Right, here's a number line, and now here's 0, and again negative 17 24ths would again be between 0 and negative 1, but it would be closer to negative 1, right? Negative 17 24ths there. And we're talking about, the solutions being all the numbers greater than this, so to the right of negative 17 24ths, and equal to, right? Or equal to, so bracket on this, or a closed point. But make sure it doesn't look like a parenthesis. That indicates that negative 17 24ths is a solution. And then the interval, looking at this piece of solutions here, right, starts off on the left at negative 17 24ths, goes to the right forever, right, so that'd be indicated by infinity. Bracket on this, parentheses on that, because infinity is not a number, and there you go. All right. Now, so far, I've been saying, hey, these are all one-step inequalities. So far, I've only performed one step, right? Subtracting 7/8 or dividing by 8 and stuff like that. Now, the ones with fractions, let me do this off to the side here. If you don't like working with fractions, which a lot of people don't, so I'll write that same inequality again. B plus 7/8 is greater than or equal to 1/6. If you don't like working with fractions, find the least common denominator, right? Find the LCD, right? Least common denominator, which in this case would be 24. Right? You have a denominator of 8, a denominator of 6. The least common multiple of 8 and 6 is 24. And then I multiply both sides by 24. Right? So I take this. Now, don't forget there. If the side has multiple terms, you're going to be distributing. So I multiply the left side by 24, the LCD, and then I multiply the right side, which is just the 1/6, by 24. And over here I'm distributing. And I'd have 24 times B plus, 24 times 7/8 is greater than or equal to, right? Still greater than or equal to because I only multiply by a positive number. And then, 6 goes into 24 4 times. Right? And so 1 times 4 on the right side there is just 4. And the whole reason for multiplying by the LCD is so all the denominators go into it evenly, right? So here, 8 goes into 24 3 times. So this becomes 3. 3 times 7 is 21. And then I would subtract 21 from both sides to get rid of the plus 21, leaving me with, 24b is greater than or equal to negative 17. And then I would divide by 24 and get b is greater than or equal to negative 17/24. Right? Exactly the same thing I got earlier. Right? Exactly the same statement I got earlier, with multiple steps. Right? Again, if you want to do this with inequalities that involve fractions, that's totally fine. You find the least common multiple of the denominators, then you multiply every term by that, and that'll get rid of the denominators. Right? I ended up with 24b plus 21 is greater than or equal to 4, and then solve, right, for the variable. But you don't have to do this, obviously, right? You saw me do this here without multiplying both sides by 24. Okay. So moving on again here, number 5. Again, pretty simple one. 6 times y is less than 48. I would simply be dividing by positive 6, and it is positive 6, so the inequality symbol won't flip. So that leaves me with y is less than 48 divided by 6 is 8. So there's the description of the solutions. All the numbers less than 8 would satisfy this. Graph on a number line. Here's 0, 8 would be to the right of 0 somewhere. And all the numbers less than 8 are to the left of 8, but not equal to 8. So a parentheses above 8 or an open point. And then interval notation, right, from negative infinity up to 8 are all these solutions. And 8 is not a solution, negative infinity is not a solution, right? So from negative infinity up to 8, negative infinity comma 8, and then parentheses on both ends for the interval. All right. Okay. Number 6, or example 6. So just as I was doing in example 3, I'm going to rewrite this. I'm going to switch sides, so that way I personally like having the variable on the left. You don't have to, all right? But I'm going to rewrite this where so instead of 40 is less than 5/8 times k, I'm going to write 5/8 times k is greater than 40. And you see how the symbol flipped when I switched sides like that. All right, and now, again, simple, get rid of the 5/8, that's multiplication. So I would divide by 5/8, but again, division by fractions is kind of ugly. So instead of dividing by 5/8, I multiply both sides by 8/5. And multiply this side by 8/5 as well, and you can think of 40 as 40 over 1. So now the left side has just a simple k, right? Because the 5's would cancel, the 8's would cancel. You have just 1k is greater than, because I multiply both sides by a positive number. It doesn't change the symbol. And then 5 goes into 40 8 times, and 8 times 8 is 64. Right, so all the numbers greater than 64 are solutions of this inequality here. Right? And then a number line. Here's 0, and again 64 would be to the right of 0 somewhere. I'll just put it there. And all the numbers greater than 64 are to the right of 64, but not including 64, so parenthesis on 64 there, or an open point. Then the interval for this, it's going from 64 to positive infinity, right? So 64 comma infinity, and parentheses on both ends, because neither of those is a solution. Again, very quick and easy. All right. Example 7 is like examples 1 and 4. where I'm going to be, adding and subtracting fractions. So here the variable is f, and I'm subtracting 13/20. So to get rid of that, I would have to add 13/20 to both sides. Right. So on the left side I have f, great, is less than, because I was only adding and subtracting. Adding and subtracting doesn't change the symbol. And then off to the side here we have negative 5/12 plus 13/20. And remember, I've said this several times now. When adding or subtracting fractions, you need a common denominator. Now, you could just multiply these to get a common multiple. 12 times 20 is 240, and get that to be the common denominator. But there is a smaller number that these both go into, and that would be 60. I could multiply the negative 5/12 here by 5 over 5 to get a denominator of 60, and multiply the 13/20 by 3 over 3 to get a denominator of 60. Right? And so we'd have here, negative 25/60, that's the negative 5/12, plus, and then 39, right, 3 times 13, 39/60. And they have this common denominator of 60, right? When you add and subtract, that common denominator stays. And you just combine the numerators. Negative 25 plus 39 is 14. All right, or 39 minus 25 is 14. And 14/60 reduces, right? This is 2 times 7. This is 2 times 30. It reduces to 7/30. Right, when you divide the numerator and denominator of that by 2. And that's as simplified as the fraction gets. All right, so f alone, and then negative 5/12 plus 13/20 is 7/30. Right, and there I have solved the inequality. Right, got the variable alone on its own side, on the left side, that like I like. And all the solutions of this inequality are the numbers less than 7/30. I'll draw that. Right, here's a number line. 0, and again 7/30 would be between 0 and 1, and it'd be closer to 0, right? Because 15/30 would be a half. 7/30 would be about half of that. So here, say here's 7/30, closer to 0 than it is to 1. And the solutions are all the numbers less than 7/30, right? So all these numbers to the left of 7/30. And not including 7/30, right? So a parentheses or an open point on the 7/30 there. And then the interval for this picture is, from negative infinity up to 7/30. Always write your intervals from left to right, and parentheses on both ends, right? Negative infinity is not a number, 7/30 is not a solution. There's your interval notation. Okay. So now we're moving along. Number 8, example 8. Again, these will be pretty quick. Just to get, this 9 times t is greater than or equal to negative 27. I simply divide by 9. Easy as that. And that's a positive 9, right? So the inequality symbol doesn't change. So I have t on the left is greater than or equal to negative 3. Right, remember, a negative divided by positive is a negative. And there you go. I have solved the inequality. Here's a number line, 0 here. Negative 3 would be to the left of 0 somewhere, right? There's negative 3. And our solutions are all the numbers greater than negative 3, so all the numbers to the right of negative 3, or equal to negative 3. This time negative 3 is included. So I have a bracket, a rectangular bracket, or a closed point, a dot above negative 3. And then the interval for this piece, this picture, is from left to right, going from negative 3 to positive infinity. Bracket on negative 3, right? Again, don't rush this. Make little 90-degree angles here. Make sure you indicate to someone that negative 3 is a solution. Negative 3 is included. And then infinity has parentheses, right? Yeah, always. Okay, moving right along. Number 9. 7/6 times j is greater than or equal to positive 42. Again, you can divide by 7/6, but again, dividing by fractions, I don't like the look of that. So I multiply by 6/7, right? Multiply by the reciprocal, that way the 6's cancel, the 7's cancel, and you're left with just j. And I do the same to the other side, multiply by 6/7, and you can think of 42 as 42 over 1 if you want. And that's a positive number that I multiply both sides by, so the inequality symbol will not change. And I have j is greater than or equal. And 7 goes into 42 6 times. And then we're just left with 6 times 6 is 36 on the right side. And there you go. The inequality is solved. All the solutions of this inequality are the numbers greater than 36 or 36 itself. Here's a number line. 0 here. 36 is to the right of 0 somewhere. There it is. All the numbers greater than 36 are to the right of it. 37, 38, 39, etc. And equal to 36, or equal to 36. Right? So bracket or a dot, solid dot above 36. Then the interval for this, right? This piece is going from 36 to infinity. Bracket on the 36, parentheses on the infinity. Right, all the numbers greater than 36 or equal to 36 are solutions. Wonderful. Right, I'm flying here. Example 10. So another one where we're just simply adding fractions. We got this g. I want to get g alone. It's being, subtracting 11/12. I'm going to add 11/12. Add 11/12 to both sides. So that'll give me g on the left is less than, right? The symbol won't flip. And then here, again, you're adding fractions, need a common denominator. Now you could multiply these, but the smallest number that both of these go into, though, is 36, right? So this first fraction, I would just have to multiply by 2 over 2 to get a denominator of 36. Second fraction, I would have to multiply by 3 over 3 to get a denominator of 36. So this is what, negative 10 36ths, right? That'd be the negative 5/18, plus, and then 33 36ths. That's the 11/12. And common denominator is 36, right? When you're adding, you keep that. And negative 10 plus 33 is the same thing as 33 minus 10. That's 23 36ths. And that's as simplified as that fraction's getting. And there we go, 23 36ths. And there's our solutions. All the numbers less than 23 36ths are the solutions of that inequality. And that would be again between 0 and 1, but this time closer to 1. So there's 23 36 on the number line. And we're looking for all the numbers, less, so to the left of that number, but not including it. All right, so parentheses are an open point above that. Then the interval notation for this piece, that's going from negative infinity on the left up to the 23 36ths on the right, and parentheses on both of those, because they're not included. They're not solutions, right? Not included. Okay. Next example, 11. Just 7 times s is less than negative 20. I want to solve for s. Just divide by 7. Very simple one. Divide by. Now this is a positive 7, so again the symbol does not flip. We'll eventually get to ones where we're dividing by a negative, right, and the symbol will flip, but we have s here is less than negative 4. And there you go. Number line. Negative 4 would be to the left of 0 somewhere. all the numbers we're looking for are the numbers less than -4, but not including -4, right? So parentheses on -4, all the numbers left of it. The interval for this would be from -infinity, right, on the left up until -4, and parentheses on both of those, right? Because again, -4 is not a solution. And you always put parentheses on the infinities. All right, number 12, or example 12. Right? Another one with a fraction. And maybe you can see, number 13 is one where I'll have to divide by a negative number. Right? But for number 12, I'm going to multiply here by 4/9 on both sides. And think of 36 as 36 over 1. The 9's cancel, 4's cancel, so I'm left with 1g on the left. I multiply by positive 4/9, so it still is less than or equal to. Then here I can do some cancellation. 9 goes into 36 4 times, and then 4 times 4 is 16. And there we go. G is any number less than or equal to 16. Number line. Here's 0, 16 would be to the right of 0 somewhere. And our solutions are the numbers less than 16 or equal to 16. So a rectangular bracket on 16 or a closed point. And then the interval for this picture, right, it's going from left to right from -infinity, right, all the way to the left forever up to 16. Always parentheses on the infinities, and then a bracket on 16 to let you know that 16 is also a solution. And there's the interval notation. Alright, so now we're getting into finally some problems where the symbol could flip. Alright, the symbol will flip. So like for this one here, I have -5 times u is greater than or equal to 65. I want u alone, so I divide by -5, and I do that to both sides. Now, as I mentioned at the very top of the video, when you multiply or divide, and it's only for multiplication or division, when you multiply or divide both sides of an inequality by a negative number, that is going to flip the inequality symbol. So this is greater than or equal to will become, is less than or equal to. So I'll have u on the left, and then instead of is greater than or equal to, is less than or equal to. Right? Don't forget to do that when multiplying or dividing both sides by a negative number. And then 65 divided by -5 would be -13. And there we go. U is less than or equal to -13. All the numbers less than -13 or equal to -13. Number line here is 0, -13 would be to the left of 0 somewhere, like there. And our solutions are all the numbers less than -13 or equal, right? So a rectangular bracket on the -13, because it is a solution. And then the interval notation for this, from left to right, be from -infinity up to -13, parentheses on infinities, and a bracket on the -13 because it is a solution. Great. All right, example 14. So here I've got, a divided by -3. Now notice that's a negative number, is less than or equal to 9. So in order to undo division, we multiply. Right? So instead of dividing by -3, if I want to get a alone, I multiply by -3, and I do the same thing to the other side. Now, just as with the last example, when you multiply or divide by a negative number, you're going to have to flip the inequality symbol. It'll change the direction of the inequality. So on the left, I'll have simply a, because the -3's cancel. This is less than or equal to becomes is greater than or equal to. Please don't forget to do that when you're multiplying or dividing by a negative number. Right? It'll change the direction of the inequality. I can't say that enough. And then 9 times -3 is -27. And there you go. Here's a description of all the solutions. All the numbers greater than negative 27 are solutions, or 27 itself. Negative 27 itself is also a solution. Number line, here's 0, negative 27 would be to the left of 0 somewhere. And our solutions are the numbers greater than negative 27 or equal to negative 27. So again, a rectangular bracket or a closed dot. And the interval for this, right, we're going from negative 27 up to infinity, bracket on the negative 27, parenthesis on infinity. Wonderful. All right, example 15. Now I want this v alone. It's being multiplied by negative 8, so I divide by negative 8 to undo that. And just as before, when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality will change. You're going to flip the inequality symbol. So now I have v on the left because the negative 8's canceled. And instead of is greater than or equal to, that's going to be, instead of is less than or equal to, it's going to be now is greater than or equal to. Flip the symbol. And then 96 divided by negative 8 would be negative 12. And there you go. Right, the variable's alone on one side. Again, I prefer it on the left myself because it makes drawing the graphs easier. And then a number line. There's 0, negative 12 is to the left of 0 somewhere like there. Right? And all the numbers greater than negative 12, right, so to the right of negative 12 or equal to negative 12 are solutions. Bracket, right, rectangular bracket, or a dot, a solid dot. And then the interval notation, right, from left to right here is from negative 12 to infinity, bracket on negative 12 to indicate that negative 12 is a solution, parenthesis on infinity as always. Right. Okay. Example 16, right, all pretty much the same now, involving all these examples at the end here involve multiplying or dividing both sides by some negative number. So like here, I'd have to multiply both sides by negative 10, right, because this b is being divided by negative 10, and if I want it alone, I got to undo that by multiplying by negative 10, and I do the same thing to the other side. And in doing so, we change the direction of the inequality, flip the inequality symbol, because you're again multiplying or dividing by a negative number. Not adding, subtracting, right? Only multiplication and division by a negative number will flip the symbol. So here the negative 10's cancel. I've got b, this is greater than or equal to, becomes is less than or equal to. Then 30 times negative 10 would be negative 300. Alright, so the solutions of this inequality are all the numbers less than negative 300 or equal to negative 300. And the graph, here's 0, negative 300 would be to the left of 0 somewhere. All the numbers less than negative 300, right, so to the left, negative 301, negative 302, etc. Or equal, right, so bracket to indicate that negative 300 is a solution. Then the interval notation for this, from left to right, this is going from negative infinity to negative 300. Always parentheses on infinities, and then a bracket on the 300, negative 300 there to indicate that it is a solution. Right, simple enough, right? Hopefully you've seen, I'm flying through these now, right? Example 17. Again, I want this c alone. I need to divide, because it's being multiplied right now by negative 9, I need to divide by negative 9 and do it to the other side. And just as the previous several examples now, when you multiply or divide both sides of an inequality by a negative number, the direction of the inequality changes. We're going to flip that symbol. So on the left side I'll have c, and instead of is less than, is greater than. And then 9 goes into 126 14 times. This would be negative 14 then. Right. And there we go. Right. And the graph, here's 0, right? Negative 14 would be to the left of 0. And we're looking for all the numbers, all the solutions of this are numbers greater than negative 14. So negative 13, negative 12, and so on to the right. but not including, right? So parentheses on negative 14, not including negative 14. And then the interval notation for this, from left to right, we're going from negative 14 to positive infinity, and parentheses on both of those because neither of those are a solution. All right, just a few more here, and all very, very, very similar. Number 18 here. Now, just to do what I've been doing, as I mentioned several times now in this video, I prefer having my variables on the left side of an inequality just to make the graph a little easier to draw. So what I'm going to do is I'm going to switch sides so that the expression with the p, the variable, is on the left. So I have p divided by negative 5, and this will flip the symbol. If I read this from right to left, it would be p divided by negative 5 is greater than negative 25. Right, so if I switch the expressions, I got to flip the symbol. Right. Okay, and then now this is just like the previous several examples. To get the p alone, I would have to multiply by negative 5. Because it's being divided by negative 5 right now. I want to undo that. Same thing over here, multiply by negative 5. And in doing this, right, when you multiply or divide both sides of an inequality by a negative number, that changes the direction of the inequality. You're going to flip that symbol. Then over here I have p is now less than, right? This is greater than becomes is less than. And then a negative times a negative is a positive, right? 5 times 25 is 125, right? This is positive 125, and there's a description of all the solutions of this inequality. Every number less than 125, and then graph this on a number line. 0, 125 would be to the right of 0 somewhere. And then we're looking at all the numbers less than, so to the left, 124, 123, 122, etc., but not equal, right? So a parenthesis on the 125, or an open point, but just to indicate that 125 is not a solution. And then the interval notation for this, from left to right, negative infinity up to 125, parentheses on both, to indicate that they're not those n values are not solutions, right? Negative infinity is not a number, so it can't be a solution, and 125 we said already was not a solution. All right, just two more of these. Negative 7 times d is greater than 105. Again, I want to get the d alone. Divide by negative 7. Right? It's being multiplied by negative 7. I want to undo that. Divide by negative 7. Do the same thing to the other side. And in doing so, right, when you multiply or divide both sides of an inequality by a negative number, that'll change the direction of the inequality. We're going to flip that symbol. So on the left side, I have d is greater than becomes is less than because of the division by negatives. And then 7 goes into 105 15 times. So this would be negative 15, right? Positive divided by negative is negative. So d is less than negative 15. And we're graphing. All right, now negative 15 would be to the left of 0. Say it's there. And our solutions are all the numbers less than negative 15. But not equal, right? So parentheses on the negative 15 to indicate that negative 15 is not a solution, or an open point. Then the interval notation for this, from left to right, you're going from negative infinity, right, because there is no left end on this picture of solutions, up to negative 15, always parentheses on the infinities, and a parenthesis on negative 15, because again, it's not a solution, and there's your interval notation for the solutions to that inequality. All right, then my last example, example 20, is very similar to example 18. What I'm going to do is just like before, I'm going to switch sides, so that way my variable is on the q is on the left. So I'll have q divided by negative 6 is less than negative 18. Right, don't forget that when I switch sides like that, the symbol's got to flip as well. Right, if you read this from right to left, it would be q divided by negative 6 is less than negative 18. That's why I've written over here. All right, and now if I want the q alone, like I do, it's being divided by negative 6. I need to multiply by -6 to undo that. Do the same thing over here, multiply by -6. And I'll set it one last time here. When you multiply or divide both sides of an inequality by a negative number, as we've done, the inequality changes direction. You flip the symbol. So now the left side I've got just the q, right, because the -6 is cancel. This is less than becomes is greater than. And then negative times negative is positive. And 6 times 18 is 60 plus 48 is 108. Yeah, 60 plus 48, 108, yes. And positive 108, right, because it's negative times negative. And there you go, all our solutions of this inequality. Any number I could replace q with to make this true. I could replace q with any number greater than 108, so 109, 110, 108.3, whatever, and this would be, the original inequality would be a true statement. Here's a number line, 0 here, 108 would be to the right of 0, say there. Every number greater than 108, right, is to the right of 108, 109, 110, 111, whatever, a billion, but not equal, right, not 108 itself. So I put a parenthesis over that, or an open point. And then interval notation, looking at this picture of solutions here from left to right, we're going from 108 to infinity. And 108 is not a solution, so parenthesis on that. And infinity is not a number, so it can't be a solution. Always parentheses on the infinity. So there's your interval notation. Great. All right. So I got 20 examples right there, solving inequalities in a single step, and then graphing them on a number line, and then writing out the solutions in interval notation. Again, hopefully you saw that in the description of the video there are time stamps for each of these, so that way you can bounce around, and you don't have to watch all 20 examples if you don't want to. You can just flip around and see what kinds I worked on. Hopefully this helps you out when you're working on similar problems, and thank you very much for watching.